Welcome everyone, Mike Fave here. Today I have a bit of a shorter study than usual, maybe about 10 to 15 minutes for this study, not like the hour-long studies that I've done in the past. And this study is going to talk about or contradict a major theory underlying some of the longevity research, which is the rate of living theory. We'll get into what that theory is in just a second, but essentially what they're showing in this study is that caloric restriction doesn't necessarily decrease the metabolic rate. And we'll get into what exactly this means and how this contradicts the rate of living theory and why that's important in just a few moments. Now, originally I had planned to do a series on cardiovascular disease, but the series has taken me quite a bit of time to create because as I dig through things, I'm finding very interesting connections. So stay tuned for that. But in the meantime, I have a couple caloric restriction videos to go through, this being the first one. And the next one will be in monkeys. So this one's in mice, just so we can see it in different species. And then we'll start to talk about maybe some of the negative side effects of caloric restriction, and then also talk about some of the more recent human studies that they have done. So stay tuned for those and stay tuned for the cardiovascular series. I don't know which ones are necessarily going to come out first. I'm really interested and excited about the cardiovascular stuff. The caloric restriction stuff I'm excited about as well, but I feel like there's a lot more practical elements with the cardiovascular stuff than necessarily the caloric restriction. Essentially, as far as the caloric restriction aspect, maybe it's not an ideal thing to do, but there are other longevity tactics that I would like to discuss in the future. So we'll keep those on the back burner and we'll cover these for now. So the study we're going to cover today is called Action of Food Restriction in Delaying the Aging Process. And we're going to jump right in here. So to set the tone for this, for longevity research and life extending research, there was a general theory that was created by a man named Raymond Pearl. You see him here on the right in the 1920s, and it was called the rate of living theory. And essentially what this theory posited or proposed was that the faster the metabolic rate was of an organism, the more it used up this vital substance that it had. And when it used up all of the vital substance, the organism died. So what they go on to say here in quotes is they say, although the expression rate of living and theory named after it are rightly ascribed to Raymond Pearl, the underlying idea and its mechanistic basis have a long ongoing evolutionary history. As originally proposed, this theory stated that the duration of life of an organism is dependent upon the exhaustion of a fixed quantity of a vital substance at a rate proportional to the metabolic rate. So essentially, the metabolic rate is slowly eating away at this vital substance. We don't exactly know what that vital substance is, at least in the context of this theory. Furthermore, they say the rate of living theory has two testable aspects: the existence of a predetermined metabolic potential and an inverse relationship between metabolic rate and aging, aka the higher the metabolic rate, the quicker the animal aged. So with a lower, ideally in this context, having a lower metabolic rate would slow the aging process, because that lower metabolic rate wouldn't burn through this vital substance. And I think Dr. Pete has referenced this in terms of like burning a candle. So if you think of the metabolic rate as the flame and you think of the wax on the candle as this vital substance, if the flame is hotter and more powerful, it'll burn through that wax faster. This was the general idea underlying this theory. Now, the study we're about to get into contradicts this pretty directly. And so it's very important to understand this because it changes the underpinnings and mechanisms into understanding what is the benefit of caloric restrictions, how is this working. So in this study, it's what they're showing, and what we're going to get into is that caloric restriction isn't actually slowing the metabolic rate, and thus by slowing the metabolic rate, increasing the lifespan. And this becomes very obviously quite important from a bioenergetic perspective, where the idea is to increase or optimize the metabolic rate and the flow of energy through the mitochondria. So let's jump into this really quick. We're going to go through the study, and then we'll go over some of the important takeaways from this, or extensions that we can start to discuss once we finish. So just a quick brief on what the outcomes of the study are. Basically, the benefits of caloric restriction may not actually be due to the lowering of the metabolic rate. I just discussed that. what they say from the study is data are presented in this report showing that food restriction can have a marked life-prolonging action in rats without reducing caloric intake per gram of body weight. I'm going to read that again because it's extremely important. Data are presented in this report showing that food restriction can have a marked life-prolonging action in rats without reducing caloric intake per gram of body weight. Moreover, the food restricted rats consumed a greater number of calories per gram of body weight during their lifetimes than did the rats fed ad libitum, yet they lived longer. Thus, the data in this report do not support the concept that food restriction slows the rate of aging by decreasing the metabolic rate. So what we're seeing here is that rats that were calorically restricted lived longer, but they actually wound up eating more calories per gram of body weight. So per gram of their body weight, they took in more energy than the rats who were fed ad libitum or allowed to eat as much as they wanted to. So essentially, the calorically restricted rats had an increased metabolic rate comparatively to the ad libitum fed rats. Now, this image isn't necessarily from this same study. There will be references on the back end, but you can see the differences in body mass between a normal lean mouse, an obese mouse, and a calorically restricted mouse. I thought the pictures were just interesting and loosely relevant to what we're talking about here. This current study didn't have much images available for adding to the presentation. So what exactly did they do in this experiment? How did they determine this? So they had a series of rats and they fed them a semi-synthetic diet that was 21% protein, 50% carbohydrate, 22% fat. Now they did describe this diet somewhere else, but I had a hard time finding what the diet actually was. We can assume it was probably, since they said semi-synthetic, probably some type of combination of starch and sucrose and vegetable oils, casein maybe as the protein source, or maybe lactalbumin or something like that, and then synthetic vitamins and minerals. So we're not talking about top of the top diet here. We're talking about, the general lab diet. So not a great diet overall. What they said then, as far as the setup, as far as the difference between the ad libitum fed rats, so the rats fed as much as they wanted, or the calorically restricted rats, what they say is that, at age 6 weeks, 230 rats were randomly selected for the longevity study. 115, called Group A for ad libitum, continued to be fed ad libitum. And 150, called Group R for restriction, were fed 60% of the mean amount of diet consumed by the Group A population. So they basically had 40% less caloric intake than the ad libitum rats. The restricted rats ate 40% less calories than the ad libitum rats. 40% is the general amount that seems to be used in caloric restriction studies. When you start restricting calories too heavily, you obviously run into problems of malnutrition, nutrients, etc. So they generally, it's not determined yet, but there's probably a Goldilocks zone with caloric restriction where too much restriction of calories creates problems that impair longevity, and then not enough restriction doesn't offer the full longevity benefit. We don't know exactly what those are yet. And this 60% was of the average amount of diet, or the mean amount of diet consumed by Group A population. So both groups were fed the diet of the composition just described, with the exception that the vitamin concentration was increased in the diet for the Group R rats, the restricted rats, in order to provide both groups the same vitamin intake. So in order to minimize any confounding effect of decreased nutrient intake, the researchers standardized the vitamin intake between the restricted rats and the ad libitum rats, since the restricted rats were going to be eating less of the provided diet overall, 40% less to be specific. Now, what happened to their lifespans? Just briefly, this isn't the main point of the study here, but essentially the restricted rats lived significantly longer than the ad libitum fed rats. So what they say here is the mean, medium, and maximum length of life of the Group A, the ad libitum rats, expressed in days, were 701 days, 714 days, and 963 days, and respectively. So for the ad libitum rats, the rats fed as much as they wanted. The average number of days that the rat lived was 701 days. The median amount was 714. And then the maximum length of time that one of the rats in the ad libitum group lived was to 963 days. Now, this is actually significantly less than the restricted rats. So in the restricted rats, the mean length of life was 986 days. So it was longer than the maximum amount of time for the rats fed ad libitum. The median amount of time was 1,047 days, and the maximum length of time was 1,435 days. So the maximum length of time for the restricted rats was almost twice as much as the mean and median length of life for the ad libitum rats, and the mean lifespan for the restricted rats was higher than the maximum lifespan for the ad libitum rats. So the caloric restriction here did indeed work. It did increase the lifespan of the rats that were calorically restricted. There's no doubt about that. And basically, the chart here is showing food intake kilocalories per day. And on the left-hand side here, we have months. And what you see is at about the 23-month mark, which is close to the 714 days, a large percentage, you basically don't see data here anymore because a lot of the rats in group A, the ad libitum rats, were actually dead at this point, whereas the restricted rats continued all the way down to this 33-month mark, which gives us about the 986 days for the mean amount of life, or the average number of days of life for the rats. So it did indeed work. The caloric restriction did increase the lifespan. Now, what we're going to get into is food intake per lean body mass. And this is where things get really interesting, because what we're going to talk about here is that the rats fed, the rats whose diet were restricted, or calorically restricted, actually ate more food per gram of body weight or per gram of, specifically for lean body mass, than the ad libitum fed rats. So what they say here is, the striking finding is that beyond age 3 months, Group R rats, so the restricted rats, consume as much or more food per gram of body weight as do Group A rats. Although the data in Table 1 are terminated at the mean length of life, this represents almost all of the lifespan of all of the rats because of the rectangular shape of the survival curves of Group A and Group R rats. Indeed, extending the analysis to 90% mortality, 10% survival point does not change the nature of the results. Calculations based on these data show that the Group A and Group R rats have almost the same food intake per gram of lean body mass. So how does this work? How are the rats that are eating a restricted diet, how are they actually eating the same amount of food per gram of body weight? Well, they weighed less. They weren't as fat as the ad libitum fed rats. So they weighed significantly less. The restricted rats weighed significantly less than the ad libitum fed rats. And if you look here, they have food intake per gram of body weight in kilocalories per gram per day. And what you see is after this 3-month mark, so they start it here at 1.5 to 2 months, because the rats were allowed to eat as much as necessary up to 6 weeks, and then they were split into the two groups at the 6-week mark. In the first month initially, or first month and a half, the ad libitum rats actually ate more than the restricted rats, but about month 3 they started to equalize, and then about month 3 to 4 you see that the restricted rats are actually eating more food per gram of body weight than the rats fed ad libitum. So the restricted rats actually have an increased metabolic rate, at least based on this metric, than the ad libitum rats. This flies in the face of the rate of living theory, and it starts to make us question as to what are the actual mechanisms of caloric restriction here if it's not slowing the metabolic rate. So we come here as conclusion is food restriction in our study did not cause a reduction in caloric intake per gram of body weight. Moreover, the restricted rats in our study consumed a greater number of calories per gram of body weight during their lifetime than did the rats fed ad libitum, yet they lived longer. Therefore, our data do not support the concept that food restriction slows the rate of aging by decreasing the rate of energy metabolism. Okay, so it's pretty clear. Essentially, the caloric restriction here is actually increasing the metabolic rate in the rats, or at least the metabolic rate is staying the same between the ad libitum fed rats and the calorically restricted fed rats, or the calorically restricted rats. Now, there's a couple things I want to point out, and so we'll get into this in the next slide. So first things first is this comparison of the rats was between ad libitum and calorically restricted. So there's an inherent problem in comparing ad libitum to calorically restricted. With ad libitum fed rats, They can eat as much as they want. They're most likely going to get fat. There are problems with the rats becoming fat, not maintaining lean body mass, the hormonal alterations, etc. Now, it's not just because they're overeating calories per se. There's other effects, and that's what leads me into these questions, or these elements here. If it's not rate of living, or it's not this decreased metabolic rate that is increasing the lifespans of rats, what could it be? What is it? So there's a couple things. In the ad libitum fed rats, there's a chance that they would have had microbiome alteration. So the semi-synthetic diet is probably garbage. Most likely some type of, again, sucrose, cornstarch, cellulose, casein, lactalbumin, whatever the deal was, and synthetic vitamins. So not the most ideal diet for rats, and definitely not ideal from a perspective of being able to regulate food intake appropriately. So you may have had microbiome alterations in the calorically restricted rats that decrease the toxic bacterial metabolites reaching their circulation. Endotoxin, lipotecoic acid, D-lactate, histamine, serotonin, etc. Any of these compounds could have been decreased in the calorically restricted mice because they would have had less of this garbage diet essentially hitting their microbiome. I've posted a couple studies on Instagram talking about the effects of granulated sugar on the microbiome. So if these rats were fed this diet, then that could be a problem there. Other elements: minimization of potentially lifespan shortening amino acids. So on the rats that were calorically restricted, there's a chance that they were getting a much smaller intake of methionine, cysteine, perhaps tryptophan, arginine, etc. That may have it's not that these amino acids are necessarily bad, but restricting them to some extent can decrease or increase the lifespan. So perhaps they were increasing the lifespan through that mechanism, and the calories may just be an associative value, especially considering the fact that we're comparing this to ad libitum fed mice. It's very important to keep in mind, because you're comparing to mice eating as much as they want, getting fat, to mice who are restricted to a certain amount and maintaining a lean body mass, etc. Next thing is, by calorically restricting the animals, they would have had less exposure to potentially damaging compounds. Those include PUFA, excess iron, heavy metals, and then also the heavily processed foods that can alter the microbiome or cause issues cellularly. Cause issues if you're eating a largely sucrose-based diet. Maybe they have enough B vitamins to prevent deficiency, but not enough to oxidize appropriately the amount of straight sucrose that they're taking in. So the calorically restricted animals could have had less exposure to these different foods. If they're using corn oil and they're decreasing their exposure to polyunsaturated fatty acids, they don't have as much as the ad libitum fed mice. Perhaps reactive oxygen species are decreased. Perhaps most of the polyunsaturated fats are being oxidized for energy rather than being stored or being incorporated in tissues. With a decrease in iron, again, decrease in reactive oxygen species and oxidative stress. Same thing with heavy metals. And then with the decreased processed food, perhaps and improvements in microbiome function, etc. So there could be multiple confounding variables here, especially considering that the diet was so poor. And again, last piece here is eating less of a generally poor diet. So if you take animals and you feed one group a really crappy diet, and you feed another group less of that crappy diet, and then allow them to get adequate vitamins and minerals, which they did in the study, it's probably likely that the mice eating less of a generally crappy diet will do better. Now, this is something that we're going to see in the next study that I go over with the rhesus monkeys. We're going to see that the composition of the diet perhaps made a large impact in the longevity outcomes for the different groups. Also, we'll see the importance of the ad libitum feeding take precedent in that study as well. And it starts to bring into question some of the caloric restriction studies and some of the benefits. Now, there seems to definitely be benefits from caloric restriction, but again, is it really just restricting the total energy, or is it through these other mechanisms? And considering that metabolism isn't lowering, we're ruling out the rate of living theory, I would assume that there's other mechanisms at play, and some of these could be part of those mechanisms. So that's essentially it for this study. This was a shorter one. The next ones I go over for the longevity or caloric restriction will be significantly longer. The Rhesus monkey study, I already have the presentation made, is just polishing up now, is significantly longer, and there's a lot more to discuss. But again, also some very interesting topics to bring in there that mirror some of the topics discussed here. So that's about it. Look forward to seeing you guys in the next one, and stay tuned for the cardiovascular series that's coming out. It's going to be pretty interesting, probably one of my better presentations. All right, take it easy, guys. See you soon.